handing over to you.
Thanks, Luke. Probably asking why I'm introducing Dave. He's been a mentor of mine for about 15 years in my career when I was in Western Australia. He's probably widened my eyes to how to ask questions in research, as well as what are the best tools to get the job done, be it data management right through to practical stuff. So I'll just introduce Dave. Dave is a principal research scientist working for the Department of Primary Industries and Regional Development in Western Australia. David has 40 years experience in nutrient management, particularly on phosphorus. He has undertaken research into various aspects of nutrient management from catchment to laboratory scale, research P absorption and availability in gravels. He's explored management practices such as riparian buffers, low water soluble P fertilisers, soil testing and effluent treatment, just to name a few.
Okay, thanks very much, Luke and Simon, for the introduction. Look, I want to start by thanking the partners involved in the work undertaken here in WA on nutrient management. So you can see some of them there on the slide. There's also a whole bunch of other people who are involved in our work, who are on our project reference group and our technical reference group, who provide us with valuable support and guidance. So look, in today's talk about nutrient management, I'm talking as much about minimising the off-site impacts of nutrients from agriculture as I am about maximising the efficiency of nutrient use by agriculture. So you'll all be aware of water quality problems around the coastal margins of Australia, usually associated with agricultural land use and fertiliser use. And the symptoms of those problems are often shown by things such as algal blooms, deoxygenation of waterways, and in some places fish kills. So agriculture has a significant role in this issue, in eutrophication. It's often the main contributor of nutrients to waterways, mainly because of the extensiveness of the industry. The nutrients from agriculture are coming from places like legacy nutrient stocks. So that's nutrients that are built up in the soil over many years of application, fertiliser application, land application of effluent, etc. And in some cases, there are also point source discharges of effluent going directly into waterways. So I guess there's things like monitoring, modelling, government and scientific reports all do a pretty good job at defining the scale of the problem and the nutrient sources. So this is just a diagram here from Southwest WA, the size of each of these pies indicating the number of tonnes of phosphorus annually getting into these estuaries, and the blue segment of the pie here represents what's coming from agriculture as we move away from densely populated areas. The urban signature tends to decrease as we move around the coast. So in terms of managing this problem, there's a range of practices that have been examined to reduce nutrient loss. And I'm talking specifically today about phosphorus as one of the primary nutrients of concern here in Western Australia. This diagram here really sums up our current state of knowledge of those practices, the varied cost benefit of those that you can see here on the x-axis, the phosphorus removal efficiency here on the y-axis, and the size of each of the circles represents the probability of adoption. And a lot of this type of information is reported again in government and scientific literature. And I guess we'd like to think that the evidence itself is enough to increase practice adoption. However, much more is required, and some of the stakeholders in this space need to change some of the things that they're doing. And it's not quite as simple as it seems. So what I'm going to focus on today is, in these management practices, is rural fertiliser management. We'll look at two projects that we've been undertaking here in the West, one called Whole Farm Nutrient Mapping and another one called uPtake, where We've had a lot of focus on the science, but increasingly we are dabbling in behavioural change because I guess all of the people involved in these programs are wanting to see some outcomes in terms of improved water quality. So I mentioned, I guess there's many stakeholders involved in an issue like nutrient management or eutrophication. And here we are down at the bottom. You can see a lot of different stakeholders there, and that's just a snapshot of them. But at the end of the day, the desired outcome is that some stakeholders make some changes. And it might be farmers adopting evidence-based fertiliser management. It might be agronomists and fertiliser companies doing things like adjusting their decision support systems to align with the latest science. Or it might be catchment support officers adjusting their messaging in interactions with farmers. But we have different stakeholders there, and perhaps we have, or need different strategies in order to get the change that we want in those different stakeholder segments. So how do we get the change we need? How do we get stakeholders to change their behaviour? All with the aim of improving water quality, whilst at the same time trying to maintain agricultural production. So this book here by Les Robinson from New South Wales and his associated course provide some very useful insights into how you might increase adoptability of practices. I'd urge you at the end of this to do a Google search for change geology. You'll find his website and the course and links to his book as well. Les, in his course, in his book, he talks about some factors that block behaviours that we want people to take up. And they're based around fear and anxiety, things like perceived risks such as embarrassment, humiliation, wasted time, financial costs, lost social status, etc. But he also talks about a need for self-protection causing too powerful, what he calls comfort zone edge effects of denial and resistance. This quote here sums up denial pretty well by a renowned economist, J.K. Galbraith. Faced with the choice between changing one's mind and proving there is no need to do so, almost everyone gets busy on the proof. And the other one, resistance, is that unwanted advice creates resistance. Reasons, facts, arguments, costs and benefits logic, when intended to persuade, create resistance. I'll show some examples shortly. But also today, even if you do have the facts, if someone shouts louder than you or gets offended by your facts, the resistance may even be somewhat stronger. So resistance can also lead to some boomerang effects where the problem you're trying to solve actually gets worse based on the strategy that you take. And a good quote here by some authors in the 1980s, if a person's behavioural freedom is reduced or threatened with reduction, he will become motivationally aroused. This arousal would presumably be directed against any further loss of freedom, and it will also be directed towards the re-establishment of whatever freedom had already been lost or threatened. So people actually seek out the banned activity more often and do it with greater fervour, enjoyment and commitment. There's been a number of studies to show that this type of signage, for example, can lead to a worsening problem rather than an improvement. And here's a few other examples that I came across recently. So Les asks if reason doesn't work, what does? And he suggests that the paths that people want to follow have properties that evoke a number of attributes. And they are things like easiness, visibility, familiarity, normalcy, and role models. And it resonated with me that there are elements of each of these in the nutrient management programs being undertaken in WA. I'll now provide some examples from the programs I talked about earlier. So the first of these is whole farm nutrient mapping program, where we go out to farms where farmers have enrolled in the program We sample every paddock on the farm according to FertCare principles, have the data analysed and interpret the data with best available science and present it as coloured maps. This is an activity that we've been doing for over a dozen years now, since 2009, and we've covered a lot of farms, sampled a lot of paddocks and a lot of ground in that time. But that's taken us about 12 years to do that. And the raw data from this exercise is in a quite inaccessible and inconvenient form in a spreadsheet. So what we do is we interpret that data and we present it in a simple traffic light symbolised map. So this, I guess, evokes easiness and also visibility, easy to interpret, highly visual. At a glance, the grower can determine the status of various soil properties on their farm, and there's about 14 maps in a report that we give to growers in workshops. On the flip side of that, beyond an individual farm, if we aggregate that data up, it's also very powerful. It clearly identifies that 75% of the paddocks contain more than enough phosphorus, and 85% of them have a soil acidity problem. And unfortunately, that excess phosphorus combined with these other constraints adds to our water quality risks. But the behavioural scientists are starting to tell us that presenting data like this to growers may just reinforce existing practices that led to this situation in the first place. But that's not to say that the science in this data is not useful. It could be very useful for other stakeholders such as funders, policymakers and the like. There's often a lot of complexity in the science and difficult language to understand. Things like response curves, relative yield, PBI, critical coal P, etc. So to remove some of the complexity in this sort of space, we introduced a thing called a fertility index. So where each of these curves here intersects this horizontal red line, all of these curves get a value of 1. So that means the critical value is at 1. Grower just needs to know if they're above or below that value. A value of 2 means you've got twice as much in your soil test as you need, and 0.5 means you've got half as much as you need. So what we've done in this space is introduce some visual cues for growers on the fertility index map that we provide to them that phosphorus application was not required. So we do that with a stop sign. We still retain the index value in the stop sign, but this is a clear signal to growers that phosphorus application based on the science is not required in those paddocks with the stop sign. Those ones that are green are marginal and they may question whether they need to apply there or not. And those ones that are red have some sort of deficiency. Again, things like the fertility index can be taken and aggregated and presented in tools like Google Earth. So in this particular case, I'm zooming in on our catchments here where we do our work, and you can see little areas of red and green there indicating different levels of fertility index. What I'm going to show you now is that not only are we using colour here to indicate the fertility index, as shown by this scale here, but we have also extruded each of the paddocks upwards from the ground to represent the index value. So in this chart, the lime green ones are the ones where you're on target, red and orange are below where you need to be, and the darker greens values are much higher than they need to be. So this is very, very insightful for us, for funders, for policymakers and the like. But again, the behavioural scientists are saying to us, well, displaying this kind of data to growers may just reinforce existing practices. They may look at this and say, oh, well, I may as well just keep on doing what I was doing. Everyone else seems to be doing this because it's an existing norm. One of the other tools that we've introduced allied with the sets of maps that we send to growers is an online calculator. It uses all of the same symbolisation as the maps in terms of the colours, etc. And growers can enter their own data and they have a practice session using this type of tool in workshops that we hold. I'll talk about that again shortly. But one of the things that it really does is it gives some of the control back to growers. They can test the waters, if you like, in terms of their nutrient soil test values, what a recommended application rate of PK or S might be before they go and have a chat to an agronomist or a fertiliser company. But it gives them back some of the control. And control is another very important element that Les talks about. Another thing in this space is that some of the stuff that we often talk about is really quite abstract. So, you know, how do we move from things like a phosphorus molecule to the light bulb going on in someone's head? So in workshops, we often commence by asking growers, has anyone ever seen any phosphorus molecules escape from their farm? And we get a lot of blank looks. Here you see some pictures taken in a face-to-face workshop setting. But some of the things that we do in these workshops is we leverage off the fact that phosphorus analysis is a colorimetric type of analysis. So what we do is we get a grower up out of the audience, we give them 2 pre-prepared vials, one contaminated with phosphorus and one not, and they put them behind their back, mix them up, give them back to us, and we say, well, I'm going to tell you which one of these is contaminated with phosphorus, put in a magic reagent, and it goes blue, depending on how much phosphorus is in there. So all of a sudden, growers understand that, well, there are laboratory procedures, we can detect this stuff, perhaps some of the science and those sorts of things that is being presented is quite real. Some of the concepts that we'd like to convey can also be out of reach of growers. So things like phosphorus adsorption, a very abstract concept that usually is only ever presented in things like graphs and using quite complex scientific language. So again, in these workshop settings, we get a couple of growers up out of the audience. I have a colleague with me. We hold on to a piece of metal each, one of which is a clay and one which is a sand. We then give the growers, two growers, 5 phosphorus molecules, and they have to race against each other to stick their phosphorus molecules on these pseudo soil types. And of course, the result is that for the clay, all of the molecules stick, and for the sand, all of the phosphorus molecules end up on the floor. But again, something to give them some familiarity about remembering how things work, and also a very visual concept. How do we go about describing things like response curves and responsiveness of pasture biomass to phosphorus additions to different soil types? We get the growers involved here, and we have some physical models that we've developed. We have some growers pouring in the equivalent of 10 units of phosphorus per year into these response tanks. Another grower reading off the scale, and we graph this up as we go. And at the end of that, we have a bit of a discussion about, what were the differences between the sand and the loam. We also do things like we remove some of the liquid out of these tanks to look at how the nutrients run down. So, if you've already got enough fertility in your soil, is it going to run down at the same rate or a slower rate than what you put it in, et cetera, et cetera. These kinds of activities have really helped to get some what are quite often difficult concepts across to growers. Now I'll move across to the uPtake project. So I guess there's no question that this project started because of a lot of denial and resistance. So the assessment of the soil test data against the evidence-based critical values that I showed you earlier didn't sit well with some industry stakeholders and growers. And I guess what a lot of the pushback was that the trials that developed these critical values were done a long time ago. Our pasture species are different. The southwest of WA is different, et cetera, et cetera. And that evolved into a federally funded smart farms project. It's a highly collaborative project, lots and lots of stakeholders, and lots of people have got their fingerprints on the design of the activities and trials, and a lot of input from those people on the project reference and technical reference groups. By the end of this season, we'll have done 52 trials, all aimed at trying to validate the critical phosphorus values that have been published in the scientific literature as a result of the National Better Fertiliser Decisions project. So there's a lot of science involved in this, a lot of pasture cuts, tissue testing, soil testing, etc. But there's some visual elements in the program that really pique a lot of interest from growers. So here you can see one particular trial that was conducted in the Peel Harvey catchment last year, and you can see some very, very visual responses to some of the treatments here. But what I want to do is focus in on 3 treatments here. So here we've got 0 kilos of P applied with nitrogen, potassium and sulfur applied as a basal nutrient. We've then got 0 kilos of P applied without nitrogen, potassium and sulfur as a basal nutrient. And then we have 40 kilos of phosphorus applied, but with no nitrogen, potassium and sulfur. So this is a site, a sandy site, that we expected to be quite responsive to phosphorus applications. And yet visually here we can see no response to phosphorus at all. It's a high rainfall year last year. And so unfortunately, all of that 40 kilos of phosphorus that was applied has been leached away. What we can see there though is significant responses to the application of nutrients such as nitrogen, potassium and sulfur. So the visual element in these trials has been a real game changer in terms of getting the message across. A lot of these trials as well, I should have mentioned, are in growers' backyards. They're spread right across the southwest in a range of different catchments so that growers can come and have a look at a field day to look at responsiveness. One of the problems we have is how do we extend the reach of all of these programs? I mentioned earlier that we've done close to 1,500 farms, but that's taken us 12 years to do that. There's something like 5,000 properties to get through, and they're managed by about 4,000 owners. So each year we conduct a review of our program. We sit down with people who are at the coalface and others, and we discuss a range of things. Now, one topic that came up in a review a couple of years ago was the opportunity to start a do-it-yourself soil sampling program. So this involves some online training, some in-field training, and here you can see some of the team. Growers bring along their own battery drill. We supply them with the sampling equipment, train them how to do it. Last year, of those people who applied to be involved in the program, 2/3 of them opted to sample themselves. We've done a lot of interviews of growers, both before and after their involvement in this program, and quite often the response for choosing do-it-yourself is because, one, they wanted to learn, but secondly, they wanted some control. They knew their farms the best, they knew where the hazards were in the paddocks, and so therefore they were in the best position to take the most representative sample in that paddock. Other things that we do to make things easier for growers and also for some of our partners is do things like develop some simple apps so that as growers are sampling their properties, they can also capture GPS coordinates for each core that's been collected in a paddock. Also, for our catchment support officers, developed apps that allow the catchment support officers to quite easily go out and interview growers and capture some feedback. So look, just before I get on to my slide to sum up, I want to show a couple of videos here that are pretty quick. So this is at one of our in-field training days, growers getting used to using various pieces of equipment, such as the sampling equipment and the apps and things that have been developed. Just moving on to the second video now. a little soundbite from a grower who was asked, having been involved in the do-it-yourself soil testing program, would he sample?
Well, I would definitely carry it out again if I may have the same support as I've had this time. I mean, it was like baby easy, you know, with everything being supplied, ready-made bags, labeled. It was absolutely user-friendly and easy to use.
And now on to our third video, which is just some responses captured during a recent online workshop. Prior to that workshop as well, some responses from some growers.
I did have one year where I actually put no phosphate on at all, which I tell you, I mean, I was scared all the way through that year that the world was going to end, which it didn't. There's not a farmer that I don't know that doesn't want to protect his land and do the right thing. Just sometimes we just need to be showed a better way than what, as I said, for me, it's what my dad did, and that's what I did, and it's worked for all these years. So changing is hard when you've been doing that all your life, but there is definitely a light at the end of the tunnel as far as I'm concerned. It's working, so I'm very happy with it.
Some of the main benefits, and the biggest one, was cost saving. And I can't stress that enough to anyone. It's, you know, not only do you save costs from fertiliser, but then you actually increase your carrying capacity. We left our carrying capacity, we were sitting around a 0.75 of a cow per hectare, and now we're up to 1-to-1 carrying capacity. And we've got more hay than we've ever cut before, more grass, and we're probably looking at, we'll just keep slowly increasing that again.
So look, just to finish up, some insights for me is it's really important to try and include some easiness, some visibility, some familiarity, some normalcy, and I guess as was expressed by some of those growers in those videos, you know, they're starting to become role models, if you like. And also, in addition to that, some other important features is to give some control back to growers, and wherever you can, to move some of the science from the abstract into the real. If you want to find out more about the Healthy Estuaries WA program and the uPtake projects, download those handouts. Thank you all very much for listening to today's webinar.